Okay, so I guess do you guys want to do a quick review of the different data structures because it's been a few weeks. Would that be good?
I think that would be a good idea.
Yeah, okay. So yeah, so people say yes. So pretty much we were talking about four main ones. We were talking about tuples, which were ordered immutable objects, which means pretty much you make it and you can't change the values in it. If you wanted to change the values, you'd have to use a different one. And it's like an ordered pair. So you could put you would use it for things like maybe if you had like coordinates like x, y, z. That's one reason you might choose to use them. And there's like many other uses, but just a big thing to know is that they're ordered, but you can't change them. Lists are mutable and they're really commonly used in Python. They're similar to an array. You can put different element types in them. So I can put in strings and then I can put in integers, and that's fine. Like unlike in other programming languages, you might not be able to do that. You assign it in the way you would assign arrays in other languages by indexing into them, and indexing starts at 0 in Python. And you would, if you're like, if you had like an empty array or you want to add something to the end, but you haven't said that the list doesn't have that size yet, you would use the word append, and you can append items to your list that way. And then we had just started dictionaries, which pretty much they're like a key value pair. So you can match, it's like a real dictionary where you'll match the key is like the word and the value is the definition. So your keys have to be immutable, but your values, you can keep changing your values, and each key is unique. So if you try accessing an element of the same key, you'll be changing your existing entry. And an example of when you might want to use that is if you're like trying to map a person's name to a list of classes they're enrolled in, you could do that, and because your value is allowed to be immutable, so you can it's allowed to be mutable, so you can make your list the value. And then we haven't gone fully to sets yet, but they're like the sets you'll talk about in math. So they're unordered and all the elements are unique. So if you try to add elements that were already in the set to them, it wouldn't do anything because they're already in them. So you can't have duplicates. And you can't index into them because they're unordered. If you wanted to access elements in the sets, there's a different way to do that. And you can modify them as a whole, but the items you put inside a set have to be immutable. So you can't make a set of lists, but you could make like a set of tuples or a set of strings or a set of numbers. You can do all of that, but you can't try to add like lists or dictionaries to a set. Did that help, or is there anything I should clarify? Okay, so then we were talking about dictionaries and the syntax, and I guess based on feedback, we're going to be trying to use these notebooks to just be able to run everything as we talk over them. So I guess the basics to begin, the basic syntax to create an empty dictionary is just these curly braces. And I could also create a dictionary with existing values, like maybe like I want to put grades, and so people are getting for classes, and I could put in the name of the class as a string and the grade as an integer value. And notice this use of the colon to separate them, separate the key here from the value, which is here. And then I can access them by using the square brackets, which is not necessarily indexing in this case. Like we saw these square brackets with lists and tuples when we were indexing into them, but here they're used to, you can put the key inside them and it'll look up whatever value you have for that key. So I can set the value of, I can add an element to dictionary 1 with the key of 10 and the value is 30. So like if I run this, it'll print that once it runs. Yeah, so you'll print that it went from being empty to, as I declared it, to having this one key value pair in it. And then here, let's say I wanted to increase existing values in it. I think we did talk about this plus equals notation to simplify, saying that you want to look up if you do this with any variable, you will take the previous value of the variable and just increment it by whatever number you put there. So now after changing the value CS31, your grade is suddenly 101%. If you wanted to look at all print a list of all the keys in a dictionary. So in dictionary 2, we have 2 keys, CS31 and EE3. We could just use this function .keys, and the way you call it is you call it on an object. So you have your dictionary 2, and you can use this .keys to just to print out all the keys in this dictionary. And you can also do that with values. So you can print out all the values in a dictionary. So you'll have 101 and 95. And then here we did have like a typo on our slide last time. So if you wanted to check if a key was in your dictionary, what you would do in Python 3 or newer is you would just use this. You just use this in keyword, which if we haven't talked about already, we'll talk about it a little bit more today. And pretty much it just lets you check that is this value in this dictionary. So with lists, I could do a similar use of the word in, and I could check if 10 is in my dictionary. And here I'm just using that with the keys, and I can do that with the keys and check, is this key in my dictionary? And I'll print false because my dictionary only had 31 and CS31 EE3. It didn't have CS32. And then this notation that we had previously in our slides, it was actually removed in Python 3. So if some of you tried running that, you would have found it wasn't working, and that's why. Yeah, and then here's like another example. So let's say you have like a dictionary that holds a counter of how much you spent on different things. So like food, and then like rent. You spent $100 in food and $2,000 on rent. And let's say you wanted to increase how much you spent on scented candles by $10. This notation, you can try running this, but it's not going to work because it's going to say that, oh, scented candle isn't in my dictionary, so I don't know how to look this up. And that'll give you an error. So a function that Python provides for you to do the same thing is this get function. And pretty much what it does is you provided this key, and it looks, is this key in my dictionary? If it is, it returns the value of that key. Otherwise, you can give it a default value to return. So like here, I set the default value to 0 because that seemed to make sense in this case. Because normally, if it's not my dictionary, that means I didn't spend anything on it. So I want to return 0. And then what this will do is try to look up scented candle in my dictionary, find that it doesn't exist, so it'll return 0, the default value, and then I can add 100 to it, apparently, instead of 10. But yeah, you can have it add to that. And now when I print out my dictionary, I added 100 and then I added 10, but you'll print out whatever values you added to it. And you can do that to avoid these kinds of errors. Is that all good? Is dictionaries all making sense? Does that, yeah? Okay, yeah, so if you want to check value, oh, yes, there should be a way to check value existence. I don't know what the function is.
You can do if blank in the dictionary name.
That's for the keys. For the values, there's a different function. I can look up the syntax and get back to you on that, but there is a way to do that. I don't know what it is. Oh, it's okay. Okay. Yeah, there's a way to do that, and I just don't remember what it is off the top of my head. Okay, yeah, I have some links on the bottom of the slides. I was like looking, so like these are not as heavy as documentation. So instead of like looking through documentation, you can look through other sources. Yeah. Can there only be one? Yeah, each key is unique. There's only one value for each key. So if I try to do something like, do like dictionary 4, and then I gave it, I give the value of 10. I had a key of 10, I gave it a value of 10. If I try to then go like this and change an index into 10 and give it a value, make a separate entry with the value of 20, when you print it, you'll see that it'll keep the newer value because it can only, the keys have to be unique, so it'll only keep one copy of the key. Does that make sense? Yeah, okay, yay. If there's no more questions, I'm going to move on to sets. Like, these slides only this only has like some of the basics, so let's just start from the beginning. So if you wanted to construct an empty set, you actually have to use this function, which pretty much, because yeah, you have to use this function. I'm not going to expand on that. If you wanted to create a non-empty set, you also use curly braces, but it has a different syntax in that you don't have to map to a value. So you don't have this colon notation that you have for dictionaries. You just have your two value. You can just put whatever items you want in your set. And if you wanted to make a set from the list, you could use the set function again and pass it a list. So my list has foo bar. I could have declared this list separately as like, I could have declared a list here, my list, but I didn't do that. You can also do that and pass it into this set function and it'll give you a set. So then here, if I run the code, the first one, I'm printing the type of set 2, which is, and it tells me, oh, it's a set, which you knew. Then I'm printing the values of each of these. So this just means it's an empty set. And then this is telling me the values are 10, 20. And here it's telling me the values are foo and bar, which are the elements of the list I passed in. So like I could also pass in to set a string and it will take apart each of the characters and put them into put each character into the set, which is kind of cool. So then if I wanted to add things to a set, I have to use the add function. So I'm going to add 30 to my set that already has 10 and 20. And I'm going to remove bar from the set that has foo and bar. And you'll see that, yep, it does add 30 and it did remove bar. So just keep in mind that add and remove is how you'll interact with adding and removing values from a set. So then here, what happens if I try to add an element in a set that already exists in the set? I kind of mentioned this earlier today. So does anyone remember? What's it going to do? Yeah, it's just going to ignore it. So it's just going to have, when I try adding 10 to it, it's going to be like, okay, whatever. I'm not going to throw an error, but I'm also not going to do anything to it. So my set's still 10, 20, 30. And it doesn't throw an error. So like, it's fine to try and add duplicates, but it's not going to do anything. And then another question, can I index into a set? So remember with tuples, what we did was we had like, if we had a tuple 10, 20, 30, I can look at the first element. And does anyone want to tell me how I would access the first element? Or not? Okay, that works too. Yeah, okay, yes, that's exactly what I do. So for tuples, I can go ahead and do this, and I can index into it. And yeah, it tells me the first element is 10. But with sets, can I do this? Yeah, you can't do that. It's going to give me an error and I'm going to be a little bit sad. Set object does not support indexing. So if you read the error, like it tells you exactly what's wrong with what you were trying to do. But yeah, just make sure you keep that in mind. And then we're going to go back to these slides. Let's hit present. So all of these, oh, there's a question. So there's no way to get a specific element in a set. There is a way to, if you wanted to access, since sets aren't unordered, you can't access them by their position in the set, but there is, if you wanted to retrieve items in the set, you can use like a for loop, which we'll talk about a little bit later, and you can use the keyword in, which I briefly mentioned earlier, and you can do like for I in your set, and that'll let you find all of the values in a set, but you won't be able to particularly be like, that's the first, that's the second, because sets are unordered. So like it doesn't, if you try to index into it, it doesn't have any special meaning. Okay, yeah. And then, so all of these data structures have more useful methods. So like for sets, there's like functions that'll do unions and intersections like you would do in math. So I had some links in the notes that I mentioned earlier, or you can just Google the documentation and see what you can do, because there's like a lot more functions associated with these data types. But we went over like the basics, and knowing that they exist is enough. Like you can look them up whenever you need them. Okay. So we have a slide with tips. So yeah, first look at the links, and you will see like some other functions you'll be able to use with sets, which is use with tuples and the other data structures, and just like knowing that they exist is enough for when you're trying to program. You'll be like, oh, so am I able to do this? And you can answer that yes or no, and then just look up exactly how to use those functions. And yeah, this will also help when deciding which data structures to use, because some operations are easier or harder with certain data structures. So like, I guess one thing, sets, we can't index into them, but for tuples we can. So like if you wanted to do something where the order was important and you wanted to be able to index into everything, you would probably not choose to use a set. Yeah. And then one of this is about performance. So like some data structure choices might be better or worse depending on what you'll be doing with them, but don't worry about this for now. Like this is not part of our scope. And then one thing you might find yourself doing is compounding these data structures. So like maybe, I think I mentioned it earlier, but saying that you could have you can't have a set of tuples, but you can't have a set with like mutable objects. So you can't have a set with like lists in them, but you could have a set with like tuples in them, and that would be fine. So you can, that's called like compounding them. And so you could do that. So perhaps like you want to keep track of all your favorite chapters and all your favorite books. Like there's many ways to do that. So like what could you do? Let me know if that was confusing also. Okay, yes, you could do that. You could do that, yeah. You wouldn't be able to change it after, but you could make like a new copy and you could have your changes. But yeah, you could do a tuple and a tuple and have your like each tuple represent a book. And you could also do a lot of different ways. So like you could do like a dictionary, and a dictionary with like tuples as the values. So like you could look up each, I'm just saying this off the top of my head, but you could like look up each book title as a string and then have it mapped to the value of, you could have it mapped to tuples that contain the chapters that you enjoyed most or something like that. We have a couple more of these actually. So yeah, if you want to, we can just go do them. We're not going to go into breakout session for this, but we're just going to go over them right now. So I guess we already did the first one. So what could you use for the second one? Like how many months you've known each of your friends? Because there's more than one answer for some of these, but for some of these there's like a more obvious, like, oh, this makes more sense to use. Yeah, a dictionary. So your key would be your each friend's name, and then the value it maps to would be the months. What about which states you visited? Yeah, you can use a set. You can also use a list, but if you don't, yeah, so both of them work. If you don't care about how many times you visited them, you might throw them in a set. But if you do care, yeah, you can still remove stuff from sets and lists. But if you care about how many times you visited them, you can add them to your list multiple times. But if you don't care, you can just put them in a set. Yeah, you can still remove them from both. What about for quiz grades for a class you're taking? I guess I kind of already did this as an example, but Yeah, dictionaries. Those work perfectly. Those would probably work the best. Or maybe if you're only trying to keep track of one class, you could throw all your grades in a set or a list. But if you're keeping track of multiple classes, a dictionary would be nice. You could also make a dictionary with like lists to hold multiple classes grades and like multiple grades for each class. And then I guess this last one, all the foods you like classified by food group. So like if you wanted to talk about, if you wanted to classify them and then say which foods you liked in that category, what could you use? So here you'd probably need something compounded. Yeah, you could do a list within a list. Are there any other ideas that people have? Okay, yeah, list within a dictionary. You can do that too, yeah. You can't put a dictionary inside. Oh yeah, you can do a dictionary with a set or a list inside. If you do a dictionary with, I'm assuming you mean as the value of your dictionary, you're trying to put a set or a list, and both would be okay. But your key has to be a immutable object. So it would be like it would have to be like a tuple or a basic type. Yeah. Okay. Yay, you all retained stuff. And hopefully this helps you like think about when you would want to use each structure. So if you come across problems, you can think about, okay, like I know these different structures exist, which one would be best to use? Okay. Oh yeah, so another example. So like, oh, okay. How would you implement that last one? Can you remind me of what the last one was? The different foods within the different groups. Okay, yeah, let's just go here for a quick second and add a new code. So if I wanted a dictionary, was it a dictionary? Sorry, I have to look at the chat again. The different foods within the different food groups. So some people said a list within a dictionary. So let's say I had a dictionary, I'm gonna call it food, and I'm gonna make it empty. And then, or do you want me to make it empty or do you want me to start with something in it? Either is fine. Okay, so let's say foods and food group, did I say desserts? I think I said desserts was one food group. So then I could put in a list here and then be like, what's in my list? Let's say I have a list of cupcakes, cakes, ice cream. Yeah, sure, ice cream. Oh, but I'm silly and I forgot to put quotes around them. Yeah, so I would be using strings, so I forgot the quotes. String cupcakes, ice cream, and then okay, I'm gonna try adding to this, appending to this after, just so if you want to see how you would add to it, but I could first do this and show that if I had them all at the start, I could go like, I could initialize it at the beginning, but let's say I only decided I was going to add puddings after. So then what I could do is I could do foods of desserts because that's my key. So I'll do desserts. Did I spell desserts wrong? No, I spelled it right. Okay, desserts. And then I would set that to, what I'd do is dot append because this part will look it up and it'll know that it's a list. And I want to append to this list. So I'll do pudding. And then I'll print foods. And it'll be, and then here we see that now pudding's in my list, in my group. And then I could do the same thing by adding different food groups. So I could add in a group for like protein. And then I could I can first like make an empty list, temporary list. So I can make a temp list with, because right now this doesn't exist in my dictionary. So I need to assign it to a list already. So I would make a temporary list and it's going to have beans, I guess. Yeah, it's going to have beans. So then I can just set it equal to temp list and then print. We're just going to print that so it for like the third time, and we'll see that now we have this new category with its new value. Was that good? Yeah, okay, glad you asked, because I think it was kind of, I went over the theory, but I didn't really explain how to do it. So yeah, thank you for asking. Okay, so another example we have is with graphs. So like there's multiple ways you could choose to represent it. And one way you could do that is you could have a list of tuples. So like this is an example just to show compound data structures again. And here, like these are directed edges. So I have like the parent to child. So 1 to 2 has an edge. So I represent this edge with 1, 2. And yeah, so graphs are very useful. You might see them in future classes, and you can use them to represent a lot, like social relationships, set of tasks that depend on each other, routes, paths more. And we have like another problem in our next set of slides that uses graphs, and I just thought they would be cool to use. So they're in here. Yeah, and then our last note was just about Python 2 versus 3. So everything we've been doing is in Python 3, and I added it in the slide after I realized that some of the functions for the dictionaries that we had the first session we had were for didn't work, and that was because they were for Python 2. So just a heads up, like some things in Python 3 and Python 2 aren't compatible with each other. So like print became a function in Python 3, and in previous versions it was used differently. And if you find yourself needing a previous version, a lot of it is similar, like the ways you can think about it are similar, but you might want to look up documentation for if you find yourself using a later version. And now we're going on to Deck 2, unless people have questions. Okay, we're going to just go on to Deck 2. So I'll give it off to Evelyn. Tell me if you want me to, when you want me to switch from slides to the notebooks.
Okay, will do. Yeah, so now we're going to be moving more from data structures over to control things. So control flow, if else, while, and for loops. So for starters, we have some operator, or I guess for starters, we have if statements, which are pretty basic. You've probably seen them before in other languages. Python does have things like if x is equal to y with the double equal sign. You can do stuff like that, but then also there are a lot of other operators that you can use in Python, which we want to make sure you're familiar with. For starters, modulus, which shows up in other places too. It just gives the remainder of a division. So like 10 mod 5, since 10 is divisible by 5, you get 0. 3 mod 2 would be 1, because if you divide 3 by 2, you have 1 remainder 1. So that remainder is what you get. So and then there are other operators that you can use for if statements that can check in other ways. So in checks to see if an object is inside a data structure. So you could say if X in my list in this case, and then it checks to see if X is inside the list. Is compares memory addresses, and or not are just other ways of writing what you might have seen in C++ of double ands or 2 bars, or not is would be an exclamation mark in C++. So it's just you write it out with text instead of with characters. And then you still have the standard math symbols of double equals for is equal to, exclamation mark equal, not equal to, greater than or equal to, less than or equal to. Maybe go over to the coding example now, just to show for if statements.
Okay, sorry, I have more. Okay, yeah, this one. I'll run this cell. I'm gonna talk over me. Okay, yes. Oh, sorry. Go ahead.
You go ahead.
Okay, so here we have a list, and it's checking if x equals y, it's going to print x equals y. But since x has a value of 10 and y has a value of 17, it doesn't print anything because this condition isn't true. And then here it's the keyword in again. So if X is in the list, X is 10, and if 10 is in our list here, it would print X is in my list. But because 10 is not in our list, it doesn't print that. And I was confused why I didn't print anything twice. So like I ran this twice. But yeah, that's why. Did you want to do the while loop here, or did you want me to go back?
Maybe I'll just do the while loop here. Yeah. So a while loop checks for conditions, and then as long as the condition is met, it keeps on running the code inside. So like basically a while loop, sorry, my voice. So this is while X is not in my list and X modulus 2 is equal to 0. So before it runs its code that's inside the while statement, it checks those conditions. So is X not in my list? Yeah, it's not in the list since 10 is not in 1, 2, 3, 4, 5. And then with the and statement, it also checks for the condition of X modulus 2 is equal to 0. That's true because 10 modulus 2, 10 divides evenly by 2 to get 5, 0 remainder, so it's 0. So then it says, okay, that condition is true. So it runs the code, which is my list append X. So X, which is 10, is added to the list. Then once that's done with that iteration of the loop, it runs the loop again. So now it says, is X in my list? And it is in the list because you just added X to the list with that code. So that condition is not true. So once that condition is no longer met, it breaks out of the loop. And then now it prints 10 is in my list. Okay, back to the slide.
Someone had a question about the modulus.
Yeah, so modulus 2 means, if you say X modulus 2, that means divide X by 2. And then like when you first started doing fractions, you would talk about how or division, it would be, oh, if we do something divided by something, then you could represent it as a whole number plus a fraction kind of a thing, where the fraction is like the remainder, if that kind of makes sense. So like modulus basically means your remainder. Yeah.
Yeah, okay, do you want me to go to the next slide?
Okay. Okay, and here we have some for loops. So there are several ways where you can approach a for loop in Python. You can do for C in my list. In this case, C is like, if in C++ you do int I equals 0 and then iterate I. C is basically like a new variable that's created and it's going to be used to iterate through this list. So this runs for every single C, which is an element of my list, and C in my list, and then print C. So it should print out A, B, C, D, E with that code. But then you can also, you don't have to just say do it for every single element in a set. You can also say do it over a range of values. So for I in range of something means that it starts at 0 and includes all integers up to, but not including the stop. So with that example aside, range 4 starts at 0, goes 0, 1, 2, 3, and then stops over 4. So for I in range of the length of my list, it would do I from 0 until the length of the list, which is 5 in length. So it goes I being 0, 1, 2, 3, and 4. So then the print statement would print 0 and then the first value in the list, A, and then 1B, 2C, 3D, 4E. So I guess also with range, you can, if you call it with more than one argument, you can specify where to start instead of starting at 0. So range 1 to 5 prints range 1 through 5 does 1, 2, 3, 4, because it says you start at 1 instead of 0. And then you can also do range with a step, which means it steps up by a certain amount each time. Yeah. And then the last example, wait, and Rita, can you explain that a little bit more?
So this is the last example. I'm just going to head over to the collab notebook, but what this enumerate function does is it takes all of your items in your list and it forms a set of tuples. So each of these tuples, I use set loosely, like not like actual, like it's just it forms a bunch of tuples where the first element in the tuple, or like the one at the index 0 of the tuple, is going to be a number I, and the second element in the tuple, or whatever is at index 1 in your tuple, is going to be the original item in your list. So if I'm just going to hop on over once it lets me escape out of here. Okay, so let's go back here. I'll run these first two, just so. But what this does is it takes your so first we have this case where it's just enumerating my list, and it's going to print each of the values. So I use T because I know this is going to give me a tuple. And then, so yeah, here we see that this first line enumerates my list. So it pretty much assigns to every value in my list an integer number. So the first element in my list was A, so it assigned it a 0, and it gives everything a numbered value. And then I just put this pause in here to be like clear when that stuff ended. And here, if I wanted to enumerate my list again, I could just access the elements of the tuple individually by using this comma here. So I would do I, comma, C, and I is like the index, or like the value that was given by the enumerate function. And then C is the item that was originally in my list. And I use C here because it was a character, because my list was just a list of these little strings. Did that help clarify what enumerate does? I'm going to assume yeah, because there was no questions, but if that might have been unclear, you can feel free to like speak up. Did you want to talk like about what these examples printed at all?
I think I kind of talked a little bit about it before, but like just once again, for C in my list, takes every single item in the list and calls it C, and then one by one goes through all the items in the list and prints them. So you see A, B, C, D, E are printed out because those are the items in the list. And then for I in range of the list means it for I from 0 to the size of the list. So I from 0 up to, but not including 5, so 0 to 4. Print I comma my list sub I means it prints from the I going from 0 to 4, and then the list value is going from 80. So you can see that printed out there.
Yeah, and I was just quickly curious, like what was the type returned by enumerating? And it gives you, it has its own object, an enumerate object, which has all these tuples here. I'm going to hop back to the slides and continue.
Okay, functions in Python. So in Python, you don't need to specify variable return types because Python just kind of guesses what value of what type of variable you need. It just figures out what you need for you. Variables are scoped to the innermost function or class in which they are assigned. So like if you create a new variable, it's only remembered in that specific scope. That's correct, yes?
Yeah.
Yeah.
So like if you create an if statement, it'll still be remembered, but if you create it in a function, or then that variable will be only relevant to that function.
Yeah, so you should create variables in the outermost scope that you want them to be known in. Yeah. So you can define a function by doing def and then the name of the function, my function in this case, and then values you want to be the inputs. So my favorite number is one input, comma, my list is another input. And then you do a semicolon at the end. And then in order to specify that the code is in the function, you have to indent into the function. And then when your function's over, you stop indenting, because Python cares about white space, unlike other languages. And it's basically like, I don't know, kind of the bracket equivalent of C++. It shows you what's in it based on the indentation and white space. Wait, is this in the code example too? Because it might be.
It should be. Yeah, wait. I have something different, but I think this is slightly better.
Okay, yeah. So this is an example of a function written in the code. So in Python, when you're doing it in more of a notebook style, you have to run the function first in order for the program to know it exists. So you could see that in Rita just ran the function. So now we can call it in any other block. If we tried calling it before we ran the block that had the function in it, it would have had an error because the function would have been defined yet. Yeah.
There's a quick question in the chat about other types beside def. Def isn't a type. We don't have to specify return value. Def is saying that we're declaring a function. Def is like the syntax for doing that. So it's not a type, it's the syntax we use. Yeah. So we don't specify the return type, and we don't have to specify the type of these parameters. So like I call them names that make sense. So like, my list is going to be a list, and my favorite number is going to be a number, but I could just use A and B and not give it a type. Yeah. Okay. Back to you, Evelyn. Do you want me to run the cell?
Okay, yeah. So in the cell, first of all, you create a list which only has one value in it, which is 3. Then we call, we make a new variable which gets assigned by calling the function. So we pass in this integer into the function and the list. So 1 becomes my favorite number in the function, and list becomes my list in the function. So it takes list and it appends 1 to it, and then prints the list. And then returns 22. So new favorite number is the value stored. New favorite number takes the value that was returned by the function, which is 22, and it's stored in my new favorite number, and then prints that. So it prints the list that it found in the function, and then prints the value that was returned, which is 22. And I believe when variables are passed into a function, they can be permanently altered by the function. So it's not like C++ where they send in a copy of the variable, they send in the actual variable into the function.
We do have slides on the special passing in, but we might skip them today due to time. But yeah, it's the way variables are passed in here is different than what you would expect, and it's a little bit complicated. But we'll get to it, maybe next quarter. Did you want to do this example now?
Okay, yeah. So here is another function example. In this block of code, we have 2 different functions. The code knows that it's 2 different functions based on the indentation. It sees the code indented under each one is only for that specific function. So this declares 2 different functions. Say hello num times, prints hello and prints hello num times many times.
Yeah.
And then countdown prints I for range start 0, -1. So starts at start and then goes to 0 by -1. So like this step can be a negative thing, and then prints this countdown thing.
Except this countdown isn't quite right, which is why I had this comment here, because I wanted to count down to print to 0, but it only prints up to 1. So does anyone know why that isn't working? think about what this range function, what the parameters for it are. Yeah, this arrow is exclusive. So like we can have negative numbers in each of these spots, and that tells us to like start from like count backwards, which is like something cool to note. But this isn't inclusive. So like if I wanted to stop at, maybe if I wanted to count to 0, I could do this. I'll count to 0, or I could print 0 separately outside of my loop. But the way I had it earlier with this 0 here, the 0 is exclusive, so it's not going to print my 0, and I was going to be sad about my countdown. Okay.
Yeah, you can also return multiple values from a function. You just have to separate them by commas. And then you could have that like in the variable you return and assign to. Functions don't need to take any parameters or return any values if you don't want them to. They just kind of exist to execute a task when you call them. Okay, so why use functions? There's some reasons. They help with organization. Instead of having a bunch of lines of code in your main routine, you can have a really simple main routine that just calls functions, and those functions call functions, and then it's just very readable what your code is doing. Example, you can have a function that's called combine list or sum elements. So you can just like name them to say what they do basically, and it makes your code very readable. Also, they are nice because of reusability to avoid duplicated code. If you've taken CS classes with Smallberg, that's one of his big points, is you don't want to duplicate code if you don't have to, because like say you have this block of code where you write it 5 different places, and then you realize you had a typo in one place and you fix that typo, but you might forget to fix it in the other places. So that way, if you call it with a function, you only have to fix it in one place. It's very nice. Also, it's just less to write in general, and yeah. And then also it's good for abstraction. You only have to call the function and parameters and return values if you want to use it.
Okay, so did anyone have questions on functions before we go on? If not, okay, I'm going to continue on, but if you come up with questions later, feel free to ask them. So one of the slides there's some more slides in here that we're going to leave out for today, but a lot of it is about like errors in Python. So you'll come across syntax errors, which is when your code doesn't follow the rules of the language, and your program will probably crash or it won't even run because Python's like, I don't understand this. This is not following the rules. So exceptions are errors that are detected during execution, and then so there's also something called logic errors, which are bugs that result in unexpected or incorrect behavior. And if you're lucky, I think this is also something you might see in classes. So like they'll talk about if you're lucky, your program will throw an exception and crash. But if you're not lucky, it'll run silently, but it'll do something that you don't want it to do. And so in Python, there's many different exceptions your program may throw. So like we saw a couple of them back when I ran some of the code back here gave me errors. So like here, I got a type error because set object doesn't support indexing. And here was another time I ran into an error. I had a key error because I was trying to look up this value. I was trying to look up this value of scented candle, of the key scented candle in this dictionary, but this key wasn't in my dictionary, so I got a key error. And then if I go back here, Yeah, you could have an index error when you're trying to access items out of bounds of your invalid indexes. So like if I had a list with 5 elements and I try to access element 5 using 5 in brackets, since indexing starts at 0 and would go up to 4, trying to do that would give me an error and my program would crash. Or if I had arguments of an incorrect type in a function, functions. If you tried to pass it into like an existing function, like let's say there's some library function performing some operation and it's supposed to only work with like strings, and the documentation says this function is to be used with strings, but you try passing it like a set, then you'll probably end up getting a type error because the program will crash saying, oh, like you can't give me this argument, I can't work with that. And like I know hopefully that makes sense. Like when you declared a function that was saying hello, we wanted to pass in an integer. And if I tried to do some of those operations that I was doing with something that wasn't an integer, I wouldn't be able to do that. It wouldn't make any sense at all. And I would probably end up crashing. Does that make sense? Oh. Okay, is there any part that I should repeat, or is that good? Let's open that. Okay, I'm assuming oh, okay, I'm good. Yay. Okay, thank you. So we have this problem here, and we have like 30-ish minutes left. Do we want to do this problem at the end, or do we and try to get through a few more things, or do we want to do the problem now and potentially not make it? Evelyn, your input. Problem at the end. Okay, yay. I'm chill with that. Okay, thank you for coming. Yeah, watch the rest of the slides and then come next quarter. Yeah, it'll be fun. Thank you for coming and participating. Let's just skip ahead for a little bit.
Yeah, let's finish the slides and we can go back and do the coding problem.
Yeah, okay. So our next thing is about using the importing libraries. So what you'll find yourself doing is that Python already has a bunch of standard libraries with a bunch of stuff already implemented. So you don't have to waste your time and energy rewriting things when you can use existing libraries. So like you'll notice that in like C or C++, if you're taking classes with them, that there's like standard libraries you're using, like the string library and stuff like that. And this is kind of Python's equivalent. So I had a couple things to here. Oh, we're gonna skip that for now. So if I wanted to import, so there's this module called numpy that has a lot of cool stuff to do with like numbers I can do, and I think that's why it's called num. I think that comes from numbers. And so like, let's say I wanted to make an array of ones and sum it up, and I don't want to use a for loop to do that. I want to be like cool and like do it without using a for loop or without writing a tedious code. What I could do is first declare my number. Okay, so what I can do is first call a function in the numpy library. So the function is called, the library is called numpy, so I imported it. So the function is called ones, and I use the syntax of using this dot between the name of the library and the name of the function. And the parameter is specifying how many ones I want, and I want 10, and I want these 10 to be of type int. I could also have type float, or I could have like double, which are decimals, but I want to go with ints. And then here I'm just gonna print it. So I have my array of 10s, and I also have a type, which is the type is an numpy nd array. And if you're familiar with classes at all, or like structures in C++ or C, where is the numpy library at? What do you mean by that? It's like a standard library that exists for like Python. So it's not something I wrote. It's like something I can import into my own code, and like I can click here and click view source. And Google Colab is smart and knows about the library and can easily include it for me or like provide it to me. So like your compilers will likely already be able to use the library, like the file exists because they access it. Now that you're writing the ones into it. No, okay, so I'm not writing ones into the, I'm using this library numpy and I'm using functions in this library. So this library has a lot of different functions. So like I can click on it. Where's the documentation? I can open a tab. Oh, yeah. So like I can look at the documentation and see that they have a lot of different functions. Which I guess it's not showing here, but yeah, there's like a lot of different functions. So you can use. It's like it is built into Python like standard library. Google Colab has it like readily importable for me, but maybe if you're on a machine, you might have to like download like the source for it before you can import it. But Google Colab is kind of convenient that it has it readily available to me. Yeah, okay. Okay, yeah, okay, thank you. I realized I might have been unclear the first time, so thank you. So we printed A, which is an array of ones, which is what I wanted. It kind of looks like a list, which is because lists are kind of like arrays, but the type when we print it is actually a numpy array, which is cool, but that's all. But like let's say I'm also lazy and I don't want to keep typing numpy before I call the functions from the numpy library. I want to just do this thing where I use this keyword as. So I'm going to import numpy as np, so I can use np to create my array. I can use np whenever I'm trying to call anything from the numpy library. So I'll do np.ones again, but this time I'm going to have 100 ones, and I'm going to use the function sum because that was my original goal. I wanted to sum my array of ones. So I'm going to use this function that numpy provides to me that will just sum them for me and print the two values here. So we'll run that. We'll see that I have 100 ones. I'm not going to count that, but there should be 100, and it sums to 100. Which is what we would expect. Yeah, and then if you have a big library, there may be many modules. So instead of wasting your space and your time trying to import so many of these unnecessary functions, you can just import the modules you need using this from import syntax. So don't worry about Fourier transforms, but that's what this FFT is fast Fourier transform. And I'm importing it from SciPy. So what I can do is use the module name that I imported, which is FFT, and then the function is also called FFT. And I can call that on A and I get some thing that looks confusing, but we don't have to worry about that. And that was just it for like the importing module stuff. Does that help make sense? Can you only do this for, no, I can do this for like a lot of, I can use, if you mean the sum function, I can use that with anything. And I can use the numpy has like a ton of like different functions I can call, but I just did ones because it was easy. So they have like a function called zeros, and that'll give me an array of zeros. I can also change values in my array. So I should be able to do like, I think I can index into them. So I can be b of 0 equals 1. Let's do a of 0 because I do other stuff to b of 0. So like a of 0 equals 0. I can print a, and oh look, it changed. So you can, these are just like functions to help you that you find yourself commonly needing, but you can do this kind of stuff with other values. Like sum will still work if I did this, or let's make it like 5. I can change it around however I want, and then I could call the sum function and it would print okay, it's gonna print 10 minus 1 plus 14. Does that help? Did I answer your question? I'm not sure if I misunderstood. Yeah, okay, yay. Yay, okay. So I'm gonna quickly go over the programming tips we had. These are stuff they'll tell you in your classes. They'll teach you to develop incrementally, and you might try to want to ignore that, but don't ignore that. Like start with the basic features and run your code as you go. That makes it easier if you end up trying to run your code at the end and you have like 20 million errors. And you're like, where did all these errors come from? It's because you should have tried running stuff as you go so you can catch those errors early on. And then if you're not sure about how something works or if there's a library that already implements it, you can try it out in the Python library or interpreter or in like a mini program or in Google Colab, just like anywhere. And that's kind of what I did when like some of you asked questions. I was like, oh, let me just like with the enumerate, I was like, so no one asked questions about that, but I was like, let me try running what the type of enumerate was just because I was curious. So you can always try out things if you're not sure, and you can also search it up. So like for existing libraries, there's already a lot of documentation, but like if you're confused on how to iterate through lists, you could easily just Google iterate lists Python, and then you'll find results that'll tell you how to do that. Or if you wanted to know how to sum my array, like I just showed you how to use numpy sum, you can search sum array in Python and you'd probably find results about numpy.sum. So like there's a lot of resources out there. Just if you can always try things, you can always Google things, and you'll probably find results helping you with what you want to do. And then for debugging, so if you have non-silent errors, so like that means it has an error message, you can search, if you're not sure what the message means, you can search up what the message you get is, and it'll probably highlight which line caused your program to crash. So you can go back through what happened and try to fix your error. So like when I made my error here intentionally up here, my error was it doesn't support indexing. So like it underlined it in red and it told me exactly what was wrong. So I could easily fix that by not trying to do this anymore, because you can't index into a set. So you can look at the error messages, and hopefully that gives you like it's good to develop an intuition as you go on about what each error means, and it'll help you as you like get more experienced. And then for logic errors and like non-silent errors, you can also, some other tips is to try your program with different inputs and values and see if that changes how your program responds. It also helps to throw in a lot of print statements. Like I do that sometimes because I'm like, I want to know what this variable has at this point, so I'll just put in a print statement, and that helps you like see inside what's happening. And you can also comment out unrelated code to isolate the problem. So if you saw me using the number sign, the pound sign symbol, that's like one way to comment out things. And then you'll get intuition about errors as you get more experienced with writing code. Evelyn, did you want to talk about like the project really quick, or like doing a project before we
Yeah, sure.
go through the
Okay.
exercise? Yeah.
So our hope with this class would be like that you guys would think about doing your own mini project over winter break, and then we can maybe share once we come back from school, just to like get some more practice. It's not little short things, not a huge deal, but like just get a little bit of practice doing Python. So if you have any ideas of your own, feel free to run it by us and go with those, or otherwise we have a lot of suggested ideas, or a few suggested ideas. Trying to like use functions to wait. Oh, sorry, you went ahead.
Sorry, I skipped ahead.
So like for doing a project, try use functions, take out repeated portions of code, and try to maybe like plan out the logic of the program in words. So like writing pseudocode before actually being the code. Start small, and like you can reach out to us if you want any kind of help, and we'd be really happy to help. Yeah, so our suggested ideas. So you can do a rock, paper, scissors game. We have some like description of how to do it. I don't know.
Yeah, you don't have to read it. It's just like pseudocode. Like they'll help you. Like if you're not sure how to get started, this could help you. Like, oh, like first I need to do this, and then these are like kind of the steps you'll need to do to implement that. And you can always ask us if you're like confused, but these are kind of brief.
And then some other things are like, could do a magic 8-ball game. So allow the user to ask a yes or no question, generate a number, allow each to correspond to a different message string. So like it could be like take in the string and then answer.
Yeah.
Another suggested idea is guess the number. So computer generates a number, user has a certain number of guesses, user enters the guess, computer tells you if your number is too high or low.
And then I think we mentioned here, if you're trying to generate random numbers, you can look into the random function that already exists. So you would like you can look up the documentation for using that, and if you're like confused, you can ask us. There's also a function called input, which is just called input parentheses, and that's how you would get inputs. So you can also look up the documentation for the parameters it takes. So like I think it takes in the what you want to display before you take the input, and you can always try it out. And you might find yourself needing that for a lot of these. So we did try to mention them here, like random. I don't think we mentioned input, but yeah.
And then we also have like a couple of suggestions for more intermediate or advanced projects. Text-based hangman game. And then also like could do something with a Twitter bot, learn how to use an API, or maybe making an alarm clock. But yeah, I don't know, just little ideas. Ideas like you can then go on your own and try and figure out how to do something, get some experience, learn a little bit of Python hands-on, and then we can come back and compare projects like in our next workshop if anyone feels comfortable with doing that.
Yeah, it'll be fun. You can always ask us for help. Like I don't expect my winter break to be interesting, so yeah. And then someone asked, is input for user input? And yep, that's exactly what it's for. Now, that was before we go to the problem we saved for the end. Please do leave us some feedback. It like helps us a lot with planning this and stuff. So like please leave us feedback. But now we're going to jump backwards. Yes, please leave us feedback like every time you attend a workshop, just so we know how to get better and yeah, know what we do well and what to improve on. And where's the problem? Oh, I skipped it, didn't I? Yeah, so this problem has to do with graphs again, and since there's some things that they're really useful, so we want to use a problem like that. And so here we give you like a directed graph like we did in the start of today when we showed you that directed graph example, and we give you like a list of tuples in the form parent child, and we want to write a function to find a collection of nodes that have 0 children. So that's the same as asking which nodes appear as children in our graphs but not as parents. We have our Google Colab notebook that was linked in that sign-in sheet is right here. And you can like make a copy of it or you can just copy the code over to like an online interpreter like we did last time. But we provided a template, like, oh, here's like the name of your function. Here's some tips if you feel stuck. Here's like an example. So like we made a graph here that has, notice that there are 5 nodes with no children. So node 4, node 8, node 9, node 20, and node 100. These have no children. So these I want to print these or like return these when I'm done with my function. And so like you can test your code using this is how we would represent this graph. In that format I specified. It's the same format we talked about here. It's the same format about each tuple represents an edge from parent to child. And we were going to have you do breakout rooms, but we can just do it in the main session. Like we can have you guys work quietly for a bit or like ask questions about it if you're all interested in doing it right now. So like we did have some hints. So like if you're not sure how to begin, a couple things to think about are which data structure could I use to represent the result I'm trying to return? So like maybe I can ask that right now and you guys can answer. If I'm trying to return all of the nodes with 0 children, which data structures could I use for that?
So like if your function, once you find all these nodes you're looking for, what would you store the nodes in order to return them?
Yeah, that's exactly what I was asking. Sorry. Dictionary. You could use a dictionary in your implementation, but you're trying to how are you thinking of using your dictionary is my question. because I did use a dictionary when I tried doing this, but I'm not sure we're thinking of using it in the same way.
It would help if we stopped recording so that people would feel less conscious
Oh
about
yeah,
talking.
let's just stop recording. Okay, thank you for those who watched the video. We'll have solutions on that one link page with all the sign-ins after, so you can like look at the solution afterwards, but we're just going to talk about it now and we're going to stop the recording.